Our entire modern world is, in a way, built on invisible forces. Think about it. Wi-Fi, radio, even the heat you feel from the sun, they all travel through totally empty space to get to us. But how? Well, the answer lies in a puzzle from the 19th century that, once it was solved, revealed this incredible, invisible rainbow of reality. So let's dive in and see how it all happened. So what is the connection between your phone, sunshine, and an X-ray? Believe it or not, the answer to all of these is the exact same fundamental phenomenon. And it wasn't discovered by some happy accident. Nope. It was found by a physicist who was hunting down a tiny, almost imperceptible flaw in the known laws of physics. Okay, let's go back in time to the mid-1800s. The laws of electricity and magnetism were pretty well established, or so everyone thought. But a brilliant physicist named James Clerk Maxwell noticed something off. There was a contradiction, a little logical impossibility lurking just beneath the surface of the equations. And this is our guy, James Clerk Maxwell. You can think of him as the detective in this story. He was looking at the case files of physics, at the established laws, and he realized there was a serious plot hole. Here's where the mystery really starts, with this imbalance. On one hand, you had a known fact. An electric current creates a magnetic field. Simple. But on the other hand, a magnetic field only creates an electric field if it's changing. It wasn't enough for it to just exist. It had to be in flux. That little difference, that lack of symmetry, that was the clue. It screamed that a piece of the puzzle was missing. And this whole problem really came into focus when Maxwell looked at a simple circuit with a capacitor. Now, a capacitor is basically just a gap in a wire, right? It's two metal plates really close to each other, but not touching. So the electric current flows up to one plate, and then it just stops. So here's how the paradox played out. Around the wire that's leading to the capacitor, everything worked just fine. The current creates a magnetic field exactly like the physics law Ampere's law said it should. But what about in the gap itself? Well, according to that same law, since there's no current flowing between the plates, the magnetic field should drop to zero. It should just disappear. And this created a massive mathematical problem. The math gave two different answers for the same spot. In physics, that is a huge red flag that your theory is incomplete. And let's be clear, this wasn't just some tiny rounding error. This was a fundamental crack in one of the pillars of physics. The laws, as they were written, were broken. This is where Maxwell had his incredible moment of genius. He didn't just find the problem, he figured out the solution. He imagined there was a kind of ghost current flowing through that empty gap. He basically asked, what if something else is going on in there? I mean, as the charge builds up on the capacitor plates, the electric field in the gap between them gets stronger and stronger. So what if that changing electric field could do the same job as a real current? And boom, that was it. He called his idea the displacement current. Now, it's not a real current. There are no electrons flowing. Instead, it's the changing electric field itself that generates a magnetic field behaving exactly like a real current would. It was the missing term in the equation. And with that one brilliant idea, everything just clicked into place. Look at how beautiful that is. A changing electric field creates a magnetic field, and a changing magnetic field creates an electric field. The laws were suddenly perfect. They were complete, elegant, and perfectly symmetrical. But, fixing the law was really just the beginning. The consequences of this new symmetry were absolutely world-changing. Maxwell had accidentally stumbled upon something profound about the very fabric of the universe. Think about it. If a changing electric field makes a magnetic field, and that new magnetic field is also changing, well, then it's going to create a new electric field, which will create a new magnetic field, and on and on and on. They could literally feed off each other in a continuous, self-perpetuating loop. And this is exactly what that loop looks like. A wave. A ripple of electric and magnetic fields that, once you get it started, can travel through the total vacuum of space, forever. It doesn't need anything to carry it along. It just sustains itself. So, naturally, Maxwell, being the mathematical genius he was, took his new, complete equations and he decided to calculate just how fast this theoretical wave should travel. The number he came up with was 300 million meters per second. Now, for physicists at the time, that number was instantly recognizable. It was, to a stunning degree of accuracy, the already measured speed of light. This was the jaw-dropping conclusion. It couldn't be a coincidence. Maxwell had just proved using only math on a piece of paper that light itself is an electromagnetic wave. In one fell swoop, he had unified electricity, magnetism, and light into a single grand theory. Just incredible. But it gets even better. His theory didn't just explain the light that we can see. It blew the doors open to a much bigger reality, an entire spectrum of invisible light that's all around us, all the time. Yeah, because his equations didn't care what the wavelength was. They predicted that these electromagnetic waves could exist at any frequency, any wavelength. The sliver of light our eyes can actually see, it turns out that's just one tiny, tiny little slice of a vast electromagnetic spectrum. And here it is, the whole shebang. Remember that question from the beginning? What connects your phone, the sun's heat, and an X-ray? Well, it's radio waves for your phone, infrared waves for heat, and of course, X-rays for that doctor's visit. They are all the same thing, electromagnetic waves, just with different wavelengths. All of this was predicted by one man who noticed a small contradiction in an old physics equation. It really makes you wonder, doesn't it? The biggest breakthroughs often come from noticing the smallest things that just don't quite add up. So, the next time a fundamental rule seems just a little bit off, remember, it might not be a mistake, it might be a doorway to a whole new reality we haven't even dreamed of yet.